Hello, algebra students. Mr. Lawrence here with your next flipped lesson. And today we're going to be learning about the real number systems. You've probably already completed your test by now, and you're getting ready for the next lesson. We're going to be starting a new unit. It's going to start with the real number systems. And some of this should be review from last year, so we're not going to spend too much time on it. But we've got to take you to a real deep place of understanding with it. Make sure you're experts at it. All right, now, why do you suppose we call them the real numbers? Well, they're numbers that literally are real. Now, in maybe Algebra 2, maybe honors geometry, but more like Algebra 2, you're going to learn something about imaginary numbers, okay? And let me just say, an imaginary number is not a number you make up, okay? Like, for example, an imaginary number is not 11. Okay, that is not an imaginary number. It is also not a number that like everybody says and they use in common speech, but isn't really a number like a zillion. You know, zillion is not a number. It's not an imaginary number. Imaginary numbers we won't deal with in here. I only mention them. They occur when you have to take the square root of a negative. Okay, so if I ask you to take the square root of -4, that would be an imaginary situation. And as we study these, I will talk about those more and more. All right, but the real numbers, they start with what are called the natural numbers. And they call them the natural numbers because they're the numbers that naturally occur. We don't really know how people started counting, but let's say that a long time ago, a shepherd had some sheep, just like this one here. Okay, and let's say he had a lot of them. Whoop, some of my sheep don't have 4 legs. Okay, not a problem. I can fix that. Yes, I have a bunch of sheep who need wheelchairs or crutches or some other device to help them walk. Okay, by the way, you know now why I teach math and not art. Okay, now, this shepherd, when he lets the sheep out during the day to go graze, okay, he brings them back to the pen. Hold on, we need a pen. Okay, so here's my pen. The shepherd has let the sheep out to go graze, and they're going to eat the grass, right? Okay, see that yummy grass there? It's a lot less expensive for him to do that than to provide food for them. Now, this is probably before people had money. Actually, would have to be. Okay, so see, there's the sheep. Ooh, minus his legs eating the grass. I better take this one. None of the legs want to move with my sheep. Okay, I think I have my leg detachment issue solved, and my sheep are going to eat their grass. Yum, 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 yum. Now, at the end of the day, when the sun is getting low, the shepherd needs the sheep to come back into the pen. The problem is numbers haven't been invented yet. He doesn't know what to do to make sure he has all of his sheep back. Now, obviously, you and I know there are 4 there, and with such a small amount, he could probably tell, oh, I have the same amount, even though he doesn't know what numbers are. But he's probably dealing with more sheep than that. So one night he gets an idea, and he says, you know what? While the sheep are sleeping, I think I'm going to find some stones, and I'm going to creep around, and I'm going to put a stone by each sheep while they're sleeping, okay? Because they won't be moving around, etc. Then, once I have put a stone by every single sheep, I'm going to collect those stones. I'll get a little bag, okay? And now, I will put the stones in the bag. Well, the morning he lets the sheep out to go graze, okay? And then in the evening comes, the sheep are coming back. Maybe, somebody that works for him is bringing him out, one of his sons. Maybe he's got a sheep dog, something like that, okay? He has his pile of stones. He takes them out of the bag, And as each sheep comes in to the pen, he puts a stone into the bag. And that way, it's the beginning of counting, okay? Now, a couple of things could happen. One, all the sheep could be back in, yet he has a stone left over. Well, one of his sheep might be missing, might be hurt. It definitely is missing. It could be lost, it could be stolen. He's got to go out and look for that lost sheep. Okay? Now, another thing that could happen is he could have all his sheep back, think he has all his sheep back. He's used up all his stones, yet there's more sheep coming. Well, he's got to figure out where these extra sheep are coming from. Are they babies? Did a mama sheep have a baby out in the field? That's a good thing because now he has more sheep. Or did somebody else's sheep get mixed in with his? Well, that's a bad thing. He doesn't want to be accused of a thief. He'll have to go return it. This is probably the way that counting started. All right. Now, eventually, what the farmer or the shepherd did, they learned to give each of those rocks a name. And, depending on what language he spoke, that would depend on the name. But we know the names as 1, 2, 3. And then he found out he needed a name for all the rocks. And the number of rocks was only limited by the number of sheep. Well, later on, they realized that those numbers could go on forever. In fact, they do. So the natural numbers start at 1, go to 2, 3, and they go on forever. They're sometimes called the counting numbers. Okay, now some important things are they don't include fractions. What are those letters? And no decimals. And there we go. My airliner is acting very strange. All right, so no fractions, no decimals. Now, short time after, well, probably a long time after, the Mayans thought of something. And they liked, with the sheep and everything, the rocks and all that, but they came up with a new number. The Mayans were the first ones to come up with the number of 0, the value of nothing. The Romans didn't know 0, the Greeks didn't know 0. Brilliant mathematicians. The Mayans were the ones who created 0, the value of nothing. So they added 0 onto the natural numbers, and they got what we call the whole numbers. Okay, and they go forever. And again, there's no fractions or no decimals. And there we are. Okay, so the natural numbers go 1, 2, 3 on forever. No fractions, no decimals. The whole numbers are almost the same exact thing, except they go 0, 1, 2, 3 on forever. No fractions, no decimals. Well, then sometime later, they came up with the concept of the negative numbers. And they call those the integers. Now, I love to use a number line to represent the integers. What you have to understand here is on this number line, we're not counting any numbers in between like 0 and 1. We're only counting 0, 1, 2, 3, -1, -2, -3, on forever in both directions. Again, just like the naturals, the wholes, and naturals and wholes, there are no fractions, no decimals. And another really cool thing is that while the naturals and wholes have no end, okay, no end on the wholes, no end on the naturals, the integers actually have no beginning. And no end. No beginning, no end. Man, this airliner is acting strange. Okay, so they don't begin because no matter what negative number you name, I can name another one smaller than it. You say -3, I can say -4. You say -4, I can say -5. You say -1000, I can say -1001. All right, so those are your three number systems. Now, some people think about them this way, and this is going to be an important concept. They think about the natural numbers fitting into this group here. All right, this contains all the natural numbers. No fractions, no decimals, etc. And then they think about the whole numbers as a circle around that. And here's why they think about it that way. If I am a natural number, do I have to be a whole number? See if you can answer that. If I'm a natural number, am I also a whole number? Name any natural number. Let's say 17. Okay? Does 17 belong in the natural numbers? Of course it does. I would get there eventually if I took 1, 2, 3. I'd get to 17 if I counted. Does it also belong in the whole numbers? It sure does. So if I'm a natural number, I'm automatically in the whole circle. You see that blue circle? I'm already in it. Okay? Now, if I'm a whole number, am I automatically a natural? Some of you are thinking yes, but that's not correct because of this guy right here, the 0. 0 is a whole number that is not natural. So it needs to be on a new circle. All right, and then they take the circle a little further and they make this the integers. And you're going to have no beginning. And no end. All right. And you see, if I'm natural, like 17, then I'm also an integer. Okay? If I'm a whole number like 0, well, then I'm also an integer. Okay, so that's your introduction to real number systems. I'm going to wrap the video up. We're going to play a game in class tomorrow. Hopefully, I'll build a better understanding of it. All right, Mr. Lawrence signing off. Good night, everybody.